Hi, welcome to Dr. Pat TV, and we're doing rates of change. This would be part 3. Okay, so rates of change, hopefully it's getting the idea across that it's basically slope. So when we're doing our calculations, we're using that slope formula. The formula that I'm using, we all know it's change of y's over change of x's. I'm using the function notation, so that's why you're seeing this f parentheses thing going on, just a function notation. And so we've got the differences of the y values for the first point, and then the second point, and then the differences of the x values on the bottom. So for an example, let's go with the function of 11x squared minus 7. And then let's do some calculations. Let's find these three questions, or three things. So we're looking to find the average rate of change over an interval that we've been given. I know that that's a square bracket right there, so we're going from 2 to 5. That is not an x value down here and a y value. These are both x values when we start talking about intervals. And then also a second question here is we need to find the average rate of change at x equals 4 with an interval of 3. And then we're looking to find the overall rate of change at x equals 6. So if you're already ready to go on these, go ahead, hit pause, do your calculations, and then see if they match what I've got. For the first question, what I'm looking at is the average rate of change over the interval of x, first x value 2, the second x value is 5. So what I'm going to do is kind of take the 2 and the 5. On the top of the fraction here, I have that 5 in the parentheses. I'm going to take the 5, go straight up to the function over here, and where I see that x, I'm going to substitute 5. Crunch it out, do all that calculation, and I got 268. Then when I've got this f of 2, that's telling me take the 2, go to the original formula where the x is, I plug in 2. So I've got 11, 2 squared minus 7. When I crunch that calculation, I now bring that result and I bring it down here to 37. That's the 37 is the result. And I plug that into that formula. And so now I'm doing 268 minus 37. 268, remember, is the y value, the value we got when we plugged in 5. 37 is the y value when we plugged in 2. And then you just crunch out the top and the bottom. You do your calculations. Got 231 over 3, and that turns out to be 77. So we got an average rate of change of 77 units per whatever the unit is. Okay, for that second question, we are looking for the average rate of change at x equals 4 with an interval of 3. As you can see, this one's slightly different than the previous question. Where the previous question we had two x values, we had an interval from going from 2 to 5. We knew the first x and we knew the second x. This one is telling us what our first x value is. It's 4, and it's telling us our interval. So the formula changes a little bit. As you can see on the bottom here, my x value, that's my first x, so that's why you're seeing f of 4. I'm starting with an x value of 4. Then, if I'm starting with an x value of 4 and have an interval of 3, that's why you're seeing inside here a 4 plus 3. Start with x, interval of 3, and on the bottom, you see that I have automatically a 3. I'm not going to calculate the x1, x2 kind of difference there. I know my interval is 3, so I just put a 3 down there. And so what I've got here, 4 plus 3 is 7. So I'm going to go up to my formula, plug in 7, and then do the calculation there, crunch it out, and I get 532. Then I take this 4 here, it's f parentheses 4. That means I take the 4, plug it into that formula up here where the x value is. That's 4 squared is 16 times an 11, and then minus a 7. That's where I got 169. And so I've calculated my y values. You're going to notice here that the 532 and the 169 do not have an f parentheses thing anymore. The f parentheses, this function notation, says take the 4, plug it into that formula, and then you write down your results. I do not write the f parentheses anymore because that's my value. 169 is my value for doing that. And then we just kind of do that subtraction at the top, and then you do your division, and I'm getting a rate of change of 121. So that's an average rate of change starting at x, has an interval of 3. If I were to look at the graph, then this would be basically a slope of 121 at x equals 4. Okay, and then for the third question, I'm looking for overall rate of change at x equals 6. And so what I've got there is, remember that overall rate is an automatically, we're starting at 0. So that's why you're seeing f of 0 here and that 0 down there. So we're starting at 0, we're going to 6, and so that's what I'm doing my calculations. With f of 6, I take my 6, I plug it in for the x value in that formula, I get a result, and the result comes down here. That's where you're seeing that 389. I plug in 0 into that formula. I do my calculations, get a result, and I plug the result down here. That's where I'm at -7. And so because I got that negative or subtraction with a negative that you're adding, so that's where that 396 is coming from. Divide by 6, and we got a nice 66. So here's an example of calculating average rate of change using the formulas when given a function. Another example I have here is just basically looking at a business example where we've got a formula for our cost. We're looking at math books, Q's the quantity of books, and total cost there. And then we want to ask, we've got these 4 questions here. Fixed costs, what's the marginal cost? What's the total cost when producing 2,000 units? And then what's the average cost per book when we have 2,000 books produced? So we're just going to find those 4 things. And once again, if you're feeling comfortable, take a moment, put this on pause, come up with your calculations, your results, and then compare to see what we've got. Okay, for the first question here, what are the fixed costs? It's really nice and straightforward when we have this nice linear situation. Fixed costs are basically those costs that have nothing to do with the number of books produced. So basically, for me calculating as a math geek, I'm just plugging in t equals 0, q equals 0, x equals 0. It's basically at the time that we're starting. So I plug 0 into that formula. That's where I'm getting the 75,000. It's the part of the function that doesn't have a variable. See, variable cost has a variable. Fixed cost doesn't have a variable because it stays the same. And so that's the other component of your fixed cost there. For that second question, what is the marginal cost per book? Well, marginal cost basically is how cost changes when you increase production. Wait a minute. Cost changing, increasing production, changing the production, that sounds like a rate of change. Change of the output over the change of input. The change of the cost over the change of the number of books that you're producing. That's slope. So when I'm looking at my linear function here, I'm looking at slope for my marginal cost. It's 2250 there. So 22.5. And so that's telling me my change in cost as the production is increased by 1 unit. That's your definition of marginal cost when you get to your econ class. So basically for us as math people, I've got a linear situation. Marginal cost is my slope. And then for that third question, I'm looking at the total cost when producing 2,000 math books. Hopefully you realize that the thing we're doing here is we're just plugging 2,000 into this formula. So this is an example or a question where we're just taking 2,000. That's the number that we're producing. We plug it in for Q. We crunch it out. We calculate. We get 120,000. So that's the answer to this one. That's our total cost when producing 2,000 units. And then for our last question, what is the average cost per book when we produce 2,000 books? The key thing is I'm looking at average cost. That's the key word for me here because that's telling me how I'm going to have to use my formula. One of our business formulas is average cost is total cost over quantity. So we've got a nice fraction. Math people call this, a nice rational function in a way. Just another way of saying fraction. So I've got my total cost over quantity. So if I want to know my average cost for 2,000, basically what I'm doing is I'm taking my total cost for 2,000, which we just calculated, so that's where you're seeing 120,000. Where did I get that? I just remembered that from the previous slide that our total cost for 2,000 units was 120,000. And then I put my production level, my quantity downstairs at 2,000, and I get equal to 60. So my average cost when producing 2,000 books is $60 per book. Now you might be thinking, Pat, dude, Dr. Pat, where's the slope on that? I mean, we've been talking about average rate of change. You've been saying, Pat, you've been saying to us all about, oh yeah, average rate of change, it's slope. So in average cost, where's the slope on that? And so I just wanted to show you a graph here. So you see in the red line here, this red line, that's the total cost graph. That would be the graph when I graphed that formula that we had. I got a graph here in terms of thousands. So at 75,000 here was my fixed cost, and then it had a nice slope of 22.5. So that's what I'm looking at there. Right here is at 2,000 here, 2,120,000 is the data point we're looking at. And so where is the slope? Well, if you look at average cost here, if I draw a line, this pink line from 0, 0 to that data point, guess what? That has a slope of 60. My average cost is equal to the slope on that TC graph. So when I'm doing average cost, I'm starting at 0, 0, and I'm just doing a nice slope here to that one data point. That's where average cost is actually a slope. It's the slope from the axes there here at 0, 0. That's what it represents, the slope of that line right there. So when we do average cost, we're actually calculating a very special type of slope. All right, so that finishes up our section on average rates of change. Talk to you later. Have a good day.